The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show. Karen, what's on the docket for today?
We're gonna make an auto sanitizing doorknob.
What the heck is that?
So a lot of times in the winter and other times of the year, people get sick and then they go and they touch doorknobs and they spread germs, and then anyone else that touches that doorknob can get sick from their germs. So we need to find a way to remove those germs from the doorknobs.
Well, we can't really dump sanitizing lotion or spray on the doorknob because then it would be hard to grip.
All slippery.
Yeah, but what if we used UV light?
Interesting concept there, Mr. Heckendorn.
Let me explain. All right, so the sanitizer is gonna have probably a long U-shaped bulb like that. So I think the first thing we should do is make an enclosure for that that's customized. So we'll 3D print it here, and then there'll be a servo attached here so it can swing around, okay? So one problem you'd have is if you had this right in front of a doorknob, they'd get in the way. Like, you know, when a person goes to grab the doorknob, they'd hit these things. So what I'm thinking is that they could rotate out of the way when they're not in use. So they swing out and they go back and forth a couple times and they swing back against the door. And that would also help with longer doorknobs, which are not round. Then what we could also do is put it at a slight angle so it actually gets more of the surface area of the doorknob when it rotates back and forth. When it folds flat against the door, it'll still be flat like that. Shouldn't be a problem. So to get started, I think I will take apart some existing hand sanitizers, then build new arm assemblies for them that attach to servos. Then we need to figure out a way to attach those to the door. And maybe while I'm working on that, Felix can get started on a circuit. So yeah, I think that's what we should try.
Seems simple enough.
And then what we can do is we can get some Petri dishes and try to get a culture sample and try to grow germs to see if it's better before or after. Let's get started.
Amazing hacks.
Where are my dragons?
Inspired designs.
Oh, look, I knocked some hot glue loose.
Regrettable acting.
I want to live in a world with Star Wars again!
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
Okay, this is a little handheld UV germ killer sanitizer. Looks like it has two, or rather one, bent fluorescent bulb inside of it. Runs off 4 AA batteries or 5-volt wall adapter. So let's just test it out for starters. There's like a rattle inside of it. It sounds like it's broken, but that's actually just a little cheap ball bearing orientation sensor because it only turns on if it's facing down. I guess so it can't give you eye cancer. Maybe this is a good time to talk about infrared and ultraviolet light. So you've seen us use infrared sensors on the show before. Infrared is just below our visible spectrum and it's red. Ultraviolet is just above our visible spectrum and it's, you know, a form of violet or blue. And it's at a higher frequency, and that's also the stuff that can hurt you or give you skin cancer. So that's why I think they don't want this to be on when it's up. We're going to defeat all those safety mechanisms for what we're going to build. They say that if all of the electromagnetic spectrum was the width of America, the amount that we can see as visible light would be the width of a human hair. Think about that, and then realize how small you are in the universe. So these are actually little miniature fluorescent bulbs, so I have to be careful I don't break them. The reason why I want to take them out of this is because I want to give them a smaller enclosure. Because if we have this thing scanning a door, it needs a point of rotation. And if the enclosure is too large, it'll stick out too far, and also the point of rotation will be out too far for this to actually affect the doorknob. That's why I want to shrink it down. Okay, here's the inside of the sanitizer wand. So we've got your plug for USB or the batteries, so you definitely don't want to hook up USB and the batteries at the same time. Here's the activation switch and the indicator light, a couple capacitors. Now, one of these isn't a capacitor, it's actually going to be that little ball bearing switch. We'll just work around that when the time comes. There's a chip on the back, probably some sort of timer because you have to hold down the button for 3 seconds. We'll see if we can defeat that as well. And the transformer is going to take the DC voltage and bump it up to AC at quite a higher voltage. Usually little fluorescent bulbs like these actually run at like 900 to 1,000 volts. Basically the same thing that used to be in laptops down along the bottom. So yeah, let me see if I can just pry this out. That's why I desoldered it, so this would actually come apart. Whatever we rebuild will have to have a shiny back to it to help bounce the light forward. There we go, the bulb. See, it's actually just one piece of glass that's been bent here. All right, so now that we have this, we need to protect it. So what I think I'm gonna do is design a 3D printed part that will hold this. Earlier we talked about our moving wand, so I'm going to make the part that actually holds this. Okay, so this represents the rubber stop in the end. These two things represent the bulb. This is the rubber stop at the bottom, and this is where the wires go. And then down here, I have a servo mount, and that's where we'll mount the little servo that actually moves this back and forth. Then around this, we have kind of the meat of the case. So I've drawn that around the bulb. Now, normally I wouldn't draw something this tight because you need a tolerance, but since the caps are rubber, we should be able to squeeze them in, so we can basically draw it at actual size without any tolerance. All right, so first I'm gonna extrude the bulb body. All right, so that's what that's gonna look like. This is pretty decent representation of what this is. And we didn't really need to draw it because we're not 3D printing the bulb, we're 3D printing the case, but this just helps us visualize that everything's gonna fit together. Then we can extrude the case itself. We can turn off the bulb. So this is what we're actually going to print. It's going to hold the bulb here, and the servo will be inset down here, and there's a hole in the bottom to allow the wires to go through. Another cool thing that we can do with Fusion 360 here is we can go in and just export this as a DXF, save as DXF. Now we can take this into Adobe Illustrator and actually make a laser cut piece that exactly matches the vectors we drew in this three-dimensional program. Because we want a 3D printed enclosure for this, but then I want a clear plastic lid on it, which will screw in place. All right, well, I'll get the 3D printer fired up and then we can assemble this. Okay, I pulled the parts off the 3D printer. Now it's time to assemble. I'm gonna drill some holes in this servo mount here. Those will line up with the holes on this mount. We actually have some slop here. See how that hole is bigger? Which is why we need additional holes in order to properly center it. And I'm gonna be doing this all with size 2 screws, I believe they are. I printed this out of PLA using the Flash Forge. Because when you print a long thing like this out of ABS, it tends to cool and contract upon itself and warp. So large and flat, PLA is the way to go.
For this part of the build, our power source is going to be a 7.4 volt lithium ion cell. On this main board here, I have our AVR board that we use a lot, a voltage regulator, and a couple of MOSFETs, and then plugs for our servos. We're controlling the servos with 2 MOSFETs, one for each servo. They are the BS170. I'll show you an example of what we got here. So right now, I'm gonna put a high to the gate of the MOSFETs. There we go, how the servo is going. It's just running a simple servo test here on the microcontroller. The gate is pulled low, so if you get rid of the 5 volts, it stops. I'm gonna try the other port here. Should do pretty much the same thing. There you go. Yep. Okay, the next thing to do is get this high voltage regulator figured out. So far we figured out that we can take this tilt sensor off, but now we're trying to figure out a way to bypass this 3-second switch.
Trying to figure out how to bypass the timer chip on this. So I've bypassed the orientation sensor. So now I go 1 1000, 2 1000, it turns on, and then you tap it again to turn it off. So I'm gonna look at the state of all these pins on this integrated circuit because it's the only integrated circuit on here. Be prepared! Yes, that's right. For some reason today we're talking about Lion King. Do you remember the 90s? Lion King was a movie in the 90s. I'm writing down the state that I find at each of these pins, And then I will turn it on, I'll activate the light and check the state again, and then I can figure out what changes. I mean, it's probably some sort of timer, but I'm never gonna be able to find a data sheet for this dinky little circuit in a cheap UV light. So this is faster. I think this one here is the LED indicator. Be prepared. Mommy, who's that? Oh, that's Hitler, dear. Who is Hitler? Well, he killed, 8 million people-ish. That's just like Lion King. All right, so no change, no change, no change, no change. So 4 of the pins changed. This one, I'm pretty sure, just involves the LED. So we had high, high, high go to low, 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 and low went to high, and the rest didn't change. So I'm thinking what we can do is probably just tie one of these low, and that should cause it to just be on permanently. I think this one here is just for the LED, so we can probably ignore it. Again, I'm not sure how they're, these transistors aren't labeled. I don't know if they're NPN or PNP. So this here could possibly be your ground power rails, I should say. I don't know that for sure, but I'm just kind of guessing. All right, so these went from high to low. So I guess the next thing to check is to manually trip some of these pins high to low and see if that turns on the main light. Yeah, we'll be prepared. Why? We're going to kill Mufasa. La 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 la. I will be king. What got us started on that? All right, so this one didn't change either. Okay, so that gives us 1, 2, 3 possibilities, and they all seem to go low. I suppose we should probably put this on the scope just to make sure there's no pulses there, because this meter can't tell us if there's actually pulses. I kind of doubt it, but we'll see. I probed around on the chip to see if there were any pulses on anything. I couldn't find any pulses. Everything is either just on or off. So I'm gonna try just pulling this. I kind of think it's this pin here. Let's see. That turns on the light, but that doesn't really help anybody. Okay, so maybe it's this one. Can you feel? Hey Felix, can you give me a hand with something? Okay, so Felix is gonna simulate MOSFETs turning this thing on. All right, plug it in. There it goes. Now I'll turn it off. That'll work. I've set up a test here using a IR emitter and an IR photodiode. So you can use these pointing at each other to detect an interrupt if something goes between them. You can also use them bouncing off of things to detect if something is there. So I have them both pointing in the same direction, and then I've got a little spacer in between them so they don't leak. And we're getting about 0.44 volts. So when I have something in front of them, even like my hand, it'll start to bounce more and more light and get a voltage change. And I'm thinking this might be a good way to trigger the doorknob. My first thought was capacitive touch, but this is connected to a door, and what if the door is not made out of wood? What if there's something inside the frame of the door where the lock goes? It just seems like, I'm not sure if that would work or not. So what I'm thinking is, we have those sensors right there, and they're kind of pointing over the doorknob, and then when you go to reach for it, you'll trip them, so to speak, and you'll get a change in voltage, which tells you that someone has opened the door. So I'm gonna print a 3D frame for these LEDs, and we'll build it into our project.
It's time for a viewer question.
So Karen, I hear you have some viewer questions for me?
Yes, one of the members on the Element 14 community was looking at building his own CNC router, and he would like some of your advice.
About what?
So, he was trying to figure out how big to make his router.
Oh, yeah.
So, a lot of times you can make them or buy them like about 4 foot by 8 foot, which is a full construction sheet, like the kind of full sheets you would get at the hardware store, or you can buy them kind of smaller. So he was wondering, is the 4 foot by 8 foot with the ease of being able to load a full sheet worth the floor space, or would you recommend getting maybe a half size or even smaller than that?
Right, so the CNC machine we have here is a full size 4 foot by 8 foot. And it is very convenient being able to put an entire sheet onto it. However, the amount of times I've actually cut an entire full sheet at once is maybe 20 times, tops. Most of the time, as in like 98% of the time, you're cutting something within the first 2 feet of the machine.
Okay.
I mean, granted, that's the kind of things we do on the show. We're making like smaller things and enclosures and whatnot. I mean, I suppose if you're making furniture with it or something larger, you might want the whole sheet at once. If you're uncertain about making an 8 foot long table, I would say maybe go 4 foot by 4 foot. That's still a very useful size, and you can just take your full stock pieces and just cut them in half once, and then they fit on the machine. I would not recommend going as small as like 2 foot by 3 foot as some of the smaller machines are, because then you're talking about multiple cuts and weird sizes to your materials. I mean, if that's all you have space for, all you can afford, then I guess that's cool. But I would say 4 by 4 foot would be the optimal size.
That sounds like some great advice, Ben.
Hope so.
So if you have any other questions you'd like Ben to answer, let us know in the Element 14 community on element14.com/TBHS.
And now, back to the build. So in our drawing, we had these arms below the doorknob. And the instructions say 1/4 inch away from the subject, so we'll try to get as close as we can. But when they fold away, then you can still get at the doorknob. I think I'm gonna put a little bit of an angle on it like that. Hey Karen, could you hold this in place for me if you're not too busy? Yeah. Dun da da, 15 degrees. So what I'm gonna do next is 3D print. Can I have that? 3D print a mount that will hold this against the door, and we'll print 2 of those. That way we can figure out the distance, and then we can build the assembly around it. We have the servo mounted to a 3D printed base at 15 degrees. I'm gonna put this here. This is a 3D printed mount I made for the IR. We'll aim it at the door handle. So what would happen is when you reach for it, your hand will bounce more light back to the IR sensor than without your hand being there. So once it sees the hand, it then waits for the hand to go away, then it waits, I don't know, 5 seconds, then turns on the lights and does a few slow passes, and of course there's one on the bottom too, and then goes back to the rest position. Okay, let's go over the parts before we hook it up to the door. So we have our 2 UV arms here, servo for each arm, and we have our IR pair here, which detects if something's in the way. Battery pack, 2 transformers for the UV, microcontroller, and a regulator for the battery pack. We have a big capacitor on there as well, because we need that to make sure the 5-volt line is nice and smooth. All right, let's give it a try. Oh, see, what we're gonna do here is install the antimicrobial device on your door handle. And yeah, it'll give you some really good results, and keep your door handles free of germs or your money back. Looks like everything's aligned. Gotta keep your door handles free of germs. It looks like something you'd use to like break into a safe. Okay, so here's how I'm gonna do the test. I'm actually going to use some Petri dishes to get a culture sample from the doorknob as is, and then we'll run the UV sanitizer and get another sample so we can compare the bacterial growth in the Petri dishes to see if it makes a difference. I haven't done any project like this since probably middle school or something like that. All right, so this is the plate. So I'm gonna actually do 2 of these, before and after, so we can see if there's a difference. And then of course, with the extra ones, we're gonna probably test everything in the shop just for kicks to see what is the most gross object. I bet it's not the bathroom. I bet it's probably either like the kitchen or a keyboard. All right, so this is before testing anything. I've been working on the doorknob all the live long day. I'm gonna do another one just to be sure. So the thing about bacteria, it's not whether or not they're there so much, it's if they're alive. You know, they talk about like, oh, you have to cook your food to a certain temperature, you know, to avoid getting sick, and you're still eating the bacteria, they've just been killed. Okay, now I need to get the doorknob dirty again, just in case I wiped off too many bacteria in that test. So our sink is like a disaster zone. Oh, bathroom doors, you need lots of bacteria here. Actually, your hands will be dirtier when you're going into the bathroom, so, oh yeah. Yeah, touching the toilet seat, touching the light switch. Disgusto hand. So I'm gonna plug in the battery. Doop, doop, da doop. I'm going to the doorknob. So why did you think we should build this? I'm gonna disconnect the battery and do another test with the cotton swabs. All right, door, we have to see if we have strep throat. Well, Karen, we let our Petri dishes stew over the weekend, for lack of a better word.
Yeah.
And we have some results.
Some of those look kind of gross.
Yeah. I kind of wish for more colors, but I guess maybe we don't have the right types of bacteria here.
Maybe.
So here's what the labeling means. So this is A and B for each type of, clean or dirty doorknob. So A meant we took a sample and we rubbed it on a Petri dish. And then B is we took another sample and rubbed it on a Petri dish. Just to make sure I got all the germs off of the doorknob, or if maybe I cleaned them all off the first time, maybe there's a difference the second time.
Okay.
I just wanted more, more variable. Okay, so this is the first sample with a dirty doorknob. There's not a whole lot of growth. Here's the second sample where I wiped it again. There's quite a bit of growth. So maybe I just missed it on the first pass.
Yeah.
But this one's pretty nasty. So if we go to the UV one, the first pass we did get some bacteria. And the second pass, it was mostly gone. But we can see that the UV one in general has a lot less bacteria than the non-UV one. So it looks like we got a positive result, although it clearly didn't get rid of all the bacteria.
Yeah.
But you don't have this big, disgusting growth. Now it's time for a research update. Karen, what's this? Is it what I think it is?
It is. Da-na-na-na.
Is that your Zelda impression?
Yes.
So one of our viewers learned that we were zero-less, and he graciously sent us in one of his Raspberry Pi Zeros.
Thanks, Rob.
We sent him some t-shirts in thanks. So yeah, this is based off the Raspberry Pi 1, I believe. And what I like about this is everything is surface mount. So whereas the normal Raspberry Pi has all that through-hole components, and if you're embedding something, you don't want that. You want something as small and flat as possible. And so the compute module kind of tried to be that, but this is a much better interpretation of that because you still have your HDMI built in, the SD card slot, everything you actually need. And what is this, like $5? That's like super
that's what
cheap.
They said.
Yeah.
$5 computer essentially.
My favorite part is it has through-hole headers, but they come empty. So if you want to add a header, you can, but if you don't, which is entirely possible, you don't have to spend the time removing the header. Honestly, I wish all the Pis were like this. That would be awesome. Yeah, so what could we do with this thing? What was that?
There are so many portable things we could make with it because it's so tiny.
What was that handheld thing that people wanted us to build? You remember that?
I think it was called a Scion?
That was some sort of oh wait, we could make like a wrist computer.
Like
Oh
a Pip-Boy?
A Pip-Boy?
You put it where the Pip-Boy goes.
Yeah, that's true.
Hey, didn't you get that really cool CRT monitor?
Oh yeah.
Is there a way you can
I'll be
combine
right back.
those two?
Yeah, let me take a look at that. I don't know if it works. This thing was built in like 2002? No, 2001. That's insane. But look, I mean, if you think about it just as a CRT, we don't know how big it is inside, but that's not that far off from what the Pip-Boy was. Well, that's all the time we have for today. Karen, I'm afraid we're gonna have to close down our Culture Club.
Do you have any ideas of how we could use an auto-sanitizing device? Let us know in the Element 14 community on element14.com/TBHS.
Where you can also read about our other upcoming episodes, builds, and special events. We'll see you next time. So I was thinking, we don't have enough money to fly this into the sun for proper disposal, so this is gonna have to do.
Fire!
Comma, chameleon. Blah, blah, blah. Blah, blah, blah. Oh, it's fun to go to the PLA. It's fun to go to the PLA. You can print things flat. It smells like burnt pancakes. Something tells me the new Batman probably doesn't have a scene where he pointlessly flies his ship up against the moon, creating an awesome silhouette. Yeah, that would be too cool for a modern movie. The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.